Hello, in this video I'm going to talk you through Fibonacci star sequences. So before I begin, Fibonacci is the name given to the star sequence because it's named after him, Leonardo of Pisa, who was the son of Fibonacci, which is why it's his nickname was Fibonacci. So the classic Fibonacci sequence that you may well have seen before begins 1, 1, 2, 3. And it's got a bit of a funny rule that you have to use to go from the previous terms to the next one. The rule is you add the two terms beforehand in order to get the next one on. So 1 plus 1 makes the 2, 1 plus 2 makes the 3. And if I wanted to get the next number in the sequence, I'd have to do 2 plus 3, which would get me 5. And then 3 plus 5 would get me 8. And then 5 plus 8 would get me 13, and so on. Okay, if we want to be technical about it, the formula for this sequence would be un, term number n in the sequence, is equal to un minus 1, 1 before, and un minus 2, 2 before. So if I wanted, for example, this number here in the sequence, which is u4, I would need to do u3 plus u2. This one here is u3, third number in the sequence, and this one here is u2. Okay. So here are a few Fibonacci sequences that I've begun. The 3 green ones are a little bit easier, but they get tricky by the time you get onto the black one. See if you can work out the missing numbers in those Fibonacci star sequences. Okay, so I'm going to go through the answers now. So in order to get the next number in a Fibonacci sequence, you add the two ones before that. So 2 plus 4 gets me 6, and then 4 plus 6 gets me 10, 6 plus 10 gets me 16, and I could keep going, but I'm going to stop there. 6 plus 7 gets me 13, 7 plus 13 gets me 20, 13 plus 20 gets me 33. And I could continue that as well if I wanted to. This is where things start to get trickier. So here, I need this one plus this one to make me the 6. So what I'm thinking is 5 plus what gets me 6. If I wanted to complicate things, I could write 5 plus x, the number that goes in there, is 6, and then solve it, which you'll see me doing later on for more complicated ones. But I imagine a lot of you can just see for yourself that it has to be a 1 in there. Okay, 5 plus 1 would make 6. So then as soon as I've got that one in there, 1 plus 6 is 7, 6 plus 7 is 13. Then from then on, it's actually going to generate the same numbers just further along than the one before. Okay, this one I am going to use algebra for because now I have 2 gaps in between. Okay, if you manage to logic yourself there a different way, then that's absolutely fine. But I'm going to go for an algebraic method. The method I'm going to go for is calling this one here x, this unknown here x. So the second number in my sequence is going to be called x. Now you might be tempted to call the next one y, and if you did, I can understand why you would do that, but I'm not going to. And the reason is, when I form algebra, I'm going to try and introduce as few extra letters, as few unknowns as possible to make my life easier when it comes to solving it. So instead of calling this y, I can actually give it a name in algebra using the Fibonacci rule, which is to add these two together. So this one here is going to be 6 plus x. Now, in order to get the 15, the rule is I have to add the 2 before it. So if I do this plus this, I should get 15. And that allows me to create an equation. So I can write x plus 6 plus x equals to 15. Okay, so I'm going to write x plus 6 plus x equals 15. And then I'm going to simplify the left-hand side. So I've got an x plus another x, which is 2 x's, plus the extra 6 to get me 15. And now I just have to go through the process of solving this. So I'm going to first of all subtract the 6 from both sides to get 2x is 9, and then divide both sides by 2 to get 9 over 2, or 4.5, 4.5. So I've now worked out x, but I've got to remind myself what x was. X was the second term of the sequence. So that's this one here. So this number here in the sequence has to be 4.5. And then I can fill the rest in using my Fibonacci rule. So 6 plus 4.5 here is 10.5. And then 10.5 plus the 15 is 25.5. And I've managed to solve the problem. You may well have had a different process that got you to the right answer. If you got there, well done, that's really good. If you can follow how the algebra works though, because it's a very powerful tool that you'll be able to use for more challenging questions later on, so it'll be very worthwhile you knowing how to do. Right, I'm now going to do more Fibonacci with algebra in. Here we are. So for these ones, that the terms themselves are algebraic, so there's no getting away from the algebra in these ones at all. I want you to see if you can work out what has to go in those gaps. They will be expressions with adding and subtracting in themselves. Okay, so you're not going to have just one letter on its own in your gaps. See what you can do with those. Okay, so looking at the first one, I'm thinking this plus something has to get me a plus 2b. Well, I've already got the a that I need. I need the extra 2b. So if I put 2b in my first gap, this plus this, yeah, that makes that expression there. So my second term has to be 2b. Now, for my next term, I have to do this plus this. And make sure when you do this that you simplify it. So it's 2b plus a plus 2b. The 2b and the 2b go together, so I can simplify it to a plus 4b. And I will normally write it in alphabetical order. So I've got my a first and then my 4b's afterwards. Okay. This one here is a little bit more complicated because I've got gaps in the middle and I've got more complicated expressions. So I'm going to focus first of all on this one here. This one here has to be added to this to get us 8x plus y. So I can write, if I want to over here, that 3x plus y plus whatever goes in my box has to get me to 8x plus y. And then I can think, well, what do I need there in order to make these two sides of the equation true? So I've got one y here and one y here, so I don't need to worry about y's. But here I've got 3x, and I need to get up to 8x. So if I put 5x in that box, that will work for me. So I'll pop a 5x in there, and now that does come out true. So if I put a 5x in there, that's the middle bit sorted. I can now do 5x plus 8x plus y to get 13x plus y for my fifth term, and then I'm just left with the first term. Now I have to think this plus this makes me this, okay? Or in other words, this minus this makes me this, okay? So whichever way of doing it you prefer is fine. Thinking about the x's first of all, 5x minus 3x is 2x. So I know I'm going to need a 2x here so that the x part works. Here I need no x's, and I've got no y's, and I've got one y here. So I'm actually going to need a minus y here, because minus y plus y is no y, okay? Or you can think of it as 0 take away 1y gets you minus 1y, whichever way of doing it makes most sense to you. Right, this one here, a little bit more complicated again, because I've got two gaps. So I'm going to, instead of introducing more algebra, I'm going to use the boxes, but you can introduce more algebra if you prefer instead. I'm going to think of this one as box. This one here is w plus 3b plus box. And then that and that has to make that. So I can say w plus 3b plus box plus another box has to get me 5w plus 18b. Because this plus this makes this. Now the boxes have to be the same as each other, okay? I'm using the same symbols, so they have to be the same. So I'm going to work out first of all what these have to make all together. So looking at the w's, I've got one w here and I've got 5 w's here. So I need 4w in order to make that work. And then looking at the v's, I've got 3v here and I've got 18v here. So I'm going to need 15v to make up the difference. But I've now got to share those evenly between these two boxes. So the w's I can see quite easily. I need a 2w in each box. This one's odd, so it's just going to mean I need a half or a decimal. So half of 15 is 7.5. So I've not got much room. Okay, so if I now make that 7.5v and a 2w, it should work out. Let's just check that I've got that correct. So the box I'm going to put 2w plus 7.5v. So if I add them together, I'm going to get 3W, and then 7.5V plus 3V is going to be 10.5V. So now, if I do these added and these added, yes, I do get what I wanted there, so it's correct. And then finally, I've got to do that plus that. So I've got 3W plus 5W is 8W, and then I've got 10.5 plus the 18, which is going to be 28.5B. One thing I will mention before I finish is that is a question that I made up myself. If you got that in GCSE, from the ones that I've seen, it's probably unlikely that they're going to give you decimals in the middle of it, but there's no reason why they couldn't, because the process works the same, the thinking is the same, it just makes the number work slightly more difficult.